So for question 3 then, we're going to have to draw this graph. And the other ones we didn't, we just had to interpret them. And this one we're going to have to draw them. Now this one might be a little different to ones that you guys done before. The reason for that is because you can see what the range is from minus 2.5 up to 2.5. So what I would suggest you do is that you get values for minus 2.5, minus 2, minus 1.5, minus 1, minus 0.5, 0, 0.5, 1, 1.5, 2, and 2.5. If you do that, then you're going to get correct. They're your x values. Remember, you fill them into the function, you get your y value, and then you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points to plot on your graph. That's what I would suggest you do, okay? So you can go about doing it that way. I'm going to pop it up. I have it done in GeoGebra, so we're going to show you there, and then we're going to answer those two questions. The values of x for where the function is equal to 0 and where the function is equal to 3. So where the function, sorry, that's going back to the question. Where the function, that's my function, okay? You can see I've done it there. 2x cubed plus x squared minus 8x minus 4. Hit enter and it gives you the graph done and dusted, okay? Now we're talking about from, we want x, if you remember, and let's put that in here now. The range that it asked you to do was between minus 2.5 and 2.5. So I can say minus 2.5. 2.5 is less than or equal to x, and x is less than or equal to 2.5. So if you hit enter on that, then it will make your graph look like that. 2. It'll block off anything else, and you can see exactly there. It goes from 2.5 or minus 2.5 up to 2.5. Okay, so again, lovely little handy tip, and again, it's something that you can check using GeoGebra after you've drawn your graph yourself. So that's our graph, and we'll go back and look at the two questions that were asked now. It said the values of x for where the function is equal to 0. So tell me now, the function is equal to 0 at 3 points in this graph. The points on the x-axis where the function hits the x-axis, okay? So there, there, and there. And there are, sorry, I'll get rid of that one. They are the functions, or they are the values of x. So x is equal to minus 2 or minus 0.5 or 2. Done. The next one it asks for the values of x for where the function is equal to 3. So where is the function equal to 3? So what we got to do now, I'm going to zoom in a little bit more so I can get 3 on it. The function is equal to 3 along that line. So it's there. I'll get that one fixed now. We move them to where it hits the x-axis, or where it hits the function at 3. A bit tricky to get our hands on. But yeah, nearly there. And there. So you can see, you can plot the 3 points. Alternatively, if I get rid of those points, and what I could do is I could put in a line where f of x is equal to 3, or y is equal to 3, and it's the points there, okay? That's where the function is equal to 3. And it's on that point, and that point. That makes it a bit easier, doesn't it? So that clocks those points for me now. And you can see the x values where the function is equal to 3 are then here. Minus 1.64, minus 1, and 2.14. Now again, they're very technical, very detailed to 2 decimal places. You wouldn't really be expected to have that. But because it's so accurate on GeoGebra, that's what's given us. Okay, so again, GeoGebra is an excellent tool to use and to do these kind of problems, to double check your work and so on. So please utilize it as best you can. Thank you.